Welcome and hello. This is a video lesson in MODSIM, and in this lesson, we're going to be talking about demand nodes. This is going to be part one about demand nodes. So what we're going to be talking about is just overview basics of a demand node. Here in the properties box, I have the general tab selected. So we're going to be talking about the general tab. And then in part two, and if we need to, part three, I'll talk about the other tabs that we see in this interface, which can change based on the selections we make. Here is the network model with a few different non-storage nodes. We have some purple demand nodes that are showing up here as the purple square, reservoir, and a sink. You can see the direction of flow in the network that's specified by the arrows. These are the links or arcs between the nodes. And if we want to add a node, there's two different types of nodes you can see here in the node palette. You can just go ahead and click the node like a consumptive demand and then click on the map and boom, here is your demand. You can just select it and then click the delete key to delete it. Or you can, I believe, right click and delete will get rid of a demand. You can also drag a demand onto the map just like that. So here's an example of flow through demand. And if you wanted to connect that demand to the rest of the network, like connect it to a different node, you can just go ahead and draw an arrow like that. So that's how that works. When you're drawing an arrow, here, let me go ahead and delete this arrow. You want to make sure to grab sort of the edge of the upstream node and then drag it to the downstream node and then just let it snap in place. If you click the node, either any type of node, click it at the very center of the node, then that's when you can move it around. So just remember, center to move it around, the edge to actually draw a link. And you want to be drawing the link from upstream node to downstream node. Okay, so I already have my network set up. I don't need to draw anything. To access the properties for any of the elements, nodes, or links, go ahead and select the element. When it's selected, you see the yellow halo. You can click on this button right here, which is Properties, and that will open up the Properties box for the selected element, which is Demand 3. Another way to open up the Properties box is just right-click on that element in the main map display, and then click on Properties. So with this Properties box open, we see we have a node name at the top, so you can rename it here, or you can just click on the label below it and then rename it. I'm just going to leave it there as Demand 3. Also, there's a description, so you can add that. And then below here, we have tabs for the actual data. So we have a general tab, a groundwater tab, and a time series tab. The general tab is what we're going to be talking about in this lesson. So the first item down here is demand node type. The options are consumptive or flow through. This is already selected because it's whatever type of demand we dragged onto the map. But the consumptive demand basically means that the demand itself gets used up and then that amount of water gets removed from the system. Examples of consumptive demand nodes would be decreed water rights, historical diversions, predicted agricultural demands, and projected municipal and industrial demands. The other type of demand here is the flow-through demand, and that has a slightly different icon. It's still a purple square, but it just looks a little different. I don't have any on the map right now. The flow-through demand does not actually consume the amount of water. What it does is that amount of water is then stored into an artificial node, and then that node is routed downstream to one or more other downstream nodes. Water satisfying the in-stream flow demand or non-consumptive demands will not be removed from the system. Some examples of flow-through demands are used for navigation, recreation, water pollution control, like dilution, as well as fish and wildlife maintenance. If I actually wanted to save this node as a flow-through demand, I'd have to go to this flow-through tab right here and then specify a non-storage node. I'm just going to make that up, click apply and OK. And you can see that the icon changed and it says flow through, so I can rename it to whatever I want. But the icon just gives me a visual indicator that this is a non-consumptive demand or flow through demand. Okay, I'm going to go ahead and change that back though. Properties, I'm going to click on general and then back to consumptive and apply. Notice as I change the demand node type from consumptive, I have a groundwater tab. And then when I changed it to flow through, the groundwater tab disappeared, the flow through tab appeared. And then as you may imagine, if I switch it back to consumptive, the groundwater tab appeared again. So we're not going to really talk about these other tabs which appear when I click general. That's what we're going to be talking about. Just like the groundwater tab and the flow through tabs going back and forth, this time series tab is associated with the selection we make here in the general tab for demand definition type. Right now it's set to time series. I believe that's the default when you create a consumptive demand. But the other option here is watch links. So when you select that, we have a watch links tab that's not only taking the place of the time series tab, but it also gets automatically selected. So we'll talk about this in probably in part 2. And then back to our general tab, the third option here for demand definition type is exchange credit. So there's no new tab, but there is an exchange credit drop-down box right here, which we'll talk about in a later lesson. Okay. Even though that's on the general tab. All right. So let's just go back to time series. So time series is the amount of flow that the demand is requiring. This is the data table. I'm going to go ahead and just arbitrarily put a 7 right there and apply. I'm going to talk more about the time series tab and adding data to this tab, a few different ways to do it, either manually, you can paste it in, or you can import it. But I'm just going to leave this at 7 for the sake of a short demonstration coming up. So let's go back to the general tab. Next up is this priority number. Now, right now I have it set to 70. I believe the default is 100, and it needs to be between 0 and 5,000. And what this is 0 represents the highest priority, which is a little bit counterintuitive because you may think, well, higher number, the better, but it's more of a ranking. So when you think of priority, think of first, like first place, most important, second place, second most important, and so on. And then again, it can range between 0 and 5,000. This priority number is converted to a cost between 0 and negative 5,000. And then that negative cost is attempted to be minimized by the LP solver to route the flow through the network. So it's really the amount of demands and the priorities that are set at each of these nodes that influence the LP solver to decide what the values of the decision variables should be, which are the flow rate through each of the links or arcs in the model. The last drop down here on this dialog box is demand information. It is the direct flow reservoir drop down. If a demand diverts water directly from a reservoir, it should be placed downstream of that reservoir, and the direct flow reservoir field should be set to the name of that reservoir. So I'm going to go ahead and pretend my demand 4 node up here gets water directly from reservoir 1. So let's go right click and edit properties for demand node 4. Now on the general tab for demand 4, I'm going to set the direct flow reservoir to the name of my reservoir, which is reservoir 1. It's the only reservoir in my network. And then what that does is this demand flow will be subtracted from the reservoir release to satisfy mass balance, as the remaining amount of release heads downstream from the reservoir 1 to what is called demand, which I think it's called, let's make this demand 3 again. Okay. I think the name changed when I switched it from consumptive to flow through and then flow through back to consumptive. So another way to look at all of these demands in a single table is to go up to the MODSIM menu and then click on cost analysis. And then in this dialog box, click on nodes. Okay, let me move this over here and resize this column. Okay, so here's a table of nodes. Each row is a separate node. We have the name of the node, the demand 4, reservoir 1, sink, demands 1, 2, and 3. We have the number. I believe this is just an ID that's associated with the database output, which we get after running the model. The type, whether it's a demand, a reservoir, a sink, the priority. These are the priorities that we actually typed into the dialog box in that general tab. So you see we have 100, that's the default value. The sink default priority is 4999, which is like the maximum, or I should say the lowest cost. This step cost field right here is just calculated as what looks like 5,000 minus the priority and then times 10. So yeah, 5,000 minus 4,999 is 1 times 10. Or I guess it would be the opposite that. So 4,999 minus 5,000 times 10 is how you get 10. Now demand 1 has I call this the highest priority, first rank. It's followed by demand 2, followed by demand 3. And then after that, you see the priority rankings right here. Consumptive demands nodes 1, 2, and 3 all have a constant demand of 7 acre feet per month. So let me go ahead and close that. And let me check my inflow up here. So properties, yeah, I have a constant 30. So basically when we run this model, let me go ahead and hit save and then run. Okay. When we run this model, the flow rate should be 30 acre feet per month. And then 7 acre feet per month should be consumed. And then so after that, we would have 23 and then 16 and then down 16 minus 7 would be 9. So let me go ahead and check the flow through this link. Yep, and the value is 9 right there. So upstream of that, I should have 16, and there's the 16. And then upstream of that, the graph shows me we have 23, and then right here would be 30. We don't have any flow upstream of demand 3. There's no flow in inflow to reservoir 1 or demand 4. Let's go ahead and change this inflow to something less than 30, specifically less than 21, so that we have a shortage in that one of our demand nodes, demand 1, 2, or 3, does not get its fully demand of 7 acre feet per month. Let's go ahead and just drop it down to 10 and see what happens. So I'll click apply, click OK. Let's revisit our table here that shows the different nodes and their priorities. So with the lowest priority, demand 1 will get its full 7. The second lowest priority right here, or I guess second highest priority, I got to figure out how to say that right, is going to get whatever's left, which is the remaining 3. And there's going to be no flow in demand 2 to demand 3. So demand 3 will get no flow in that situation. Let's go ahead and save the model and then run it and see what happens. So go ahead and click OK. So let's go ahead and check this node for its plot data, and there's no flow. And then that means the flow between demand 1 and demand 2 should be 3. So there's the 3 right there. We can even get the numbers if we wanted to open up this table. Okay, so there's the flow 3. This is a 1-year simulation at a 1-month time step, just the default settings there. But if I switch the priorities so that demand 3 has a higher priority than demand 2, then the flow would be 10, 3, 3, 0 instead of 10, 3, 0, 0. Let's do that and then call it good for this lesson. So I'm going to go to, let's change them at the same time. And you can do that by going up to the cost analysis nodes table right here. Okay, let me resize that column again. And then what did I say? How about let's just change this demand 3 right here from 7 down to 55. So it's a higher priority than 60, but still lower than 50. So I'm going to click OK. And then I'm going to save the network. And then let's run it. And then click OK. Now this node right here should have our flow of 3 acre feet per month. So let's check that out. Graph. And boom, there's our 3 for the entire simulation. Okay. Well, that was it for this lesson. What we talked about was demand nodes in MODSIM. This was just part 1, where we talked about the general tab in the properties editor dialog box and then did a quick demonstration.